Hey!
Hello everybody.
Get the mouse out of my face.
What up?
Alrighty, so
What up?
what up with you? We
So
haven't,
basically, it's been like 2 months break.
we haven't broadcasted anything.
Yeah. So basically, my computer blew up, and we just thought that we're gonna start with a new project.
Yeah, summer and so many other things to do that the old project kind of died down. So now we had fresh ideas of what else to build.
Yeah.
Yeah, and to just summarize what we did last time, we built this web application, and we went from scratch to setting up the server and getting everything running. And now we just like to focus on one thing and not get that all over the field. As in the sense that last time during one stream we introduced so many different subjects and really didn't teach anything in that process.
Yeah. So this time we just want to take one thing and do that.
Yeah,
And
one
that
subject.
one thing is test-driven development.
Yeah. So how would you summarize test-driven development?
You make test, you drive.
You drive. Basically in software there are these things called tests that you can write, and what they basically do, they just check if your software works the way you intended it to work. For that we're going to use unit tests, and the thing that these tests have developed is a kind of a culture where you Sess is installing the our editor in the background, so until he's finished I'll just introduce the concept of test-driven development.
Yay!
So anyway, people started to write tests to see if the software works, and at one point this came up with this kind of an idea that, hey, why not write the test before actually writing the software? So you kind of have like this criteria that you say that, hey, my software has to be able to do thing X, and you can always run the test, and the test will fail if your software can't do the thing called X. So the software development using test-driven development turned out to be something in the sense that you're going to think of what is the best way that some kind of feature should work or should be accessible, and you write that test for it, and now you need to write the software that will make that test pass. If that concept is kind of like weird or difficult to understand, or maybe you aren't a programmer yourself, then I'll just name out some of the advantages that this test-driven development will have over, let's say, a development where you write the code first and then a test, or a development where you don't write tests at all. So maybe you can summarize what would be advantage of having tests at all. I mean, if you compare a software that doesn't have tests and a software that has tests, what are the advantages of having software that has tests?
So basically, if you have a small project, then not having tests is not that bad. But if the project grows and grows and grows, then the more tests, the better. So basically, each time you do something new, you have the tests to rely on that your old stuff will work.
Yeah.
And if you want to make a project that's big and that you can develop as fast as you did before, then you have to maintain the project, and building tests. Building tests is like the way to do it.
Yeah, kind of like an example of let's say we're not building software, we're building a car, right? So we build a car and we say that, hey, this car has to be able to make a 90-degree turn at a speed of, I don't know, something like 40 kilometers. Right, and you make a test, and the test basically is that, yeah, drive the car at 40 kilometers and try to do a 90-degree turn, and then see if the car is able to take that turn. So that's a test, right? So you do all these kind of requirements, different requirements, like you need to be able to open a door with a key, and you have like this bunch of tests. And now, if you want to improve that car, let's say, hey, I want to put in this great speaker system that has like these huge, heavy speakers in it. Like you put them in there. And what the test gives you the opportunity is that after you have modified your car, you run the tests and see if everything passes. So let's say that now, when you put the new speakers in the car's weight has skyrocketed. The car is really heavy. It goes 40 kilometers an hour at the turn, and it doesn't take the turn. It will just go off road or go off the road and crash and burn. So then your test will tell you, hey, now you can't make any more of these 90-degree turns. So you'll be aware of this. And that's kind of the concept of the test, that you have like these requirements specified, and you can just easily run them, and with basically 1 second, you like get an answer that yes, the software will still work, or you have broken something with your modifications.
So do we need Java for testing?
Yep, we need Java and we need Maven, so we need to download the JDK. You're on the right page.
This one?
Yes, we need that.
Yay!
So I guess we'll just have to set up the environment. What we're currently doing, we just installed our IDE, the IDE development tool. That's the IntelliJ, because we like that. And we also need Java. It's a Java development kit that we're currently installing. What that will give us, that when we write some kind of code, then the Java development kit will be able to compile the code and run it. So we can actually test to see if it works. Yeah, just installed everything. That's pretty cool.
So is the stream working? Oh yeah, we have a viewer. Awesome! Awesome! Okay, let the chat be here. So if you want to say anything, comment or point out our mistakes and anything, just do it. We are here to learn and just mess around with code.
Yeah. So basically, those are the unit tests. There's tons of different kinds of tests out there. For example, some new thing that I learned are fitness tests. What they do is they measure the performance in the sense that if you make some kind of changes to the software and the software becomes slow because of those changes, the fitness tests are going to be the ones that will fail. An example of a fitness test would be the front page of a website has to load within 2 seconds. That's basically a fitness test. Or if you press submit on a registration form, the answer should be in your mailbox within 5 seconds. That's another fitness test. So those are kind of like, yeah. Standard Party was the name. Yeah. Anyway, so what are we gonna be unit testing? It's gonna be a game idea that we had. We're not really sure how far we will get with the game idea during the first session, but the idea is of an asymmetrical game where we have.
Whoa! That's way too huge.
Wait.
Way too huge.
All right.
We want a battle room where monsters are just bashing each other.
All right. So this time we're just gonna try to have some kind of Java code that would represent a player and a monster, or a hero and a monster, and then try to simulate combat. And what we're going to be doing is we're going to be writing tests. For example, if player of level 2 with a sword of that attacks a goblin, then we expect the goblin to die. And that would be basically an example of a test scenario that we want to write. So we want to set up like whole, like, I don't know, we'll find out how many tests, but we want to set up some kind of test like that, and then we just want to build a code that would implement that. So software-wise, no UI, nothing to play during the first time. So I just kind of try to fight the sun as it reflects off the screen right into our eyes. So anyway, we're not gonna be programming any UI, no website, no server, just pure Java and some tests, and then just to practice some test-driven development.
At least this time, yes.
Yeah.
So,
next time, something else.
What do we need to make tests?
All right. Now that you had Java installed, I want to be sure that it got installed. So I'm gonna check it on the command line. So if we write, how was that? It was echo, right?
Java C does not work. You can just go Java C.
Alright, I can do that. Yeah. And we don't have Java C. What about Maven? MVN? There's no Maven either. So we need to install those. Yeah.
So does it need to compile on the thing?
Actually, I'm not sure. Maybe we can manage it without. Let's see if we can. Yeah, the best way is let's write a test. Let's see if it works.
Yeah.
This is great test-driven development. Alrighty, so over here we have our IntelliJ open, And what we're doing, we're using a Maven project structure, or a Maven project. And what that does, it provides a structure for our projects to use. It will create this folder, source folder, and it has in there main folder. This is basically where we would write all of your source code for the project, and in there we have a folder for Java code. If you would have different kind of programming languages, you might have them right here next to the Java folder as well, like you have Java and maybe something is done in C or C++, you'd have a folder for that. But anyway, we have a Java folder, we're going to put source code over here, and we have a tests folder, and over there we have a Java folder as well, and we're going to be writing our tests for the Java code in there. So, we're just going to run test to see if you can even run tests. So for that, we're just going to create new Java class, test.
What are we testing?
We're basically testing if the testing framework works, I guess.
Maybe we can just start with a hello world test. So to make the test work, we need to write a basic hello world program or a function that returns hello world.
Hello tests. Okay. It generated some comments. I'm just going to remove those. Don't want them down here. And
oh! Yeah, we don't want that.
all right. So now we need to configure a bit of this either, as it seems to have some kind of settings that we don't like.
Alright. Where is it now? Where is it? Allow caret in anywhere? So was it something like that?
Yeah, it was something like
And
that.
the fly. Okay, awesome.
All right. So now what was it called?
Caret.
Carrot. So yeah, we don't want it jumping around the screen. How testing works? You write this method, public method. It will be void, means it doesn't return anything. This is just a method that can be run.
Oh wait, can we do something like this?
Yeah, we can generate it. Now, I was thinking about just writing it out, but yeah, to be a better programmer, you can always generate code, so you don't have to write it out like a peasant.
Peasant!
So anyway, what Sander did was generate a bunch of code.
So yeah, I used a combination of alt insert.
Alt insert will open up the generation menu, and from there you have different kind of codes that you can generate for your current class you're in. So just remember that shortcut was alt insert.
Actually, just we don't want to get into shortcuts. That
I think shortcuts are good.
So basically, if you want to know something about shortcuts, press Ctrl-Shift-A, and you can just search like
inline. I like inlining. Now I have all the different methods that have inline in them.
Yeah, or if you want to find, you just go find, and then
all the different shortcuts.
Find. Yeah, so you have the combinations here as well. So you just go, or you want to refactor, you just go.
Yo, dog, this is shortcut for shortcuts. Hello.
Yes.
Alrighty. So what did that generate for us? It generated a method. I'll be getting back to this line over here in a second. I'll just quickly explain this one here. It generated a method for us with a simple test name, and it just says that this might throw an error, but whatever about that. And over here you would write your test, and then it's defined with an annotation. In Java you have these annotations that begin with an @, and with that you basically tell the Java the testing framework that this here is a test, and if you're gonna run tests, you should run this one as well. So that's how you mark a test for your project. You just write annotation of a test in front of it. As you can see at the moment, we don't have JUnit, so we should
get JUnit.
Yeah, there's two ways to get a JUnit. Using Dida, it will just immediately provide these methods for you. One is add a JUnit jar. That will basically take the JUnit jar from somewhere and put it in your project. Or we can add a Maven dependency. Maven was the project type that we used. You can use this to define all kinds of different libraries that your project might want to use. And using this add Maven dependency, it will define that this JUnit framework is something that you want to have in your project. So I'm just going to click that. It's going to try to search for it from the servers, that if there's a testing framework for that. For some reason it doesn't work. Let's see if it works like this. Maybe I need to put that. No. What if I search for an artifact? JUnit. All right. So if the search functionality in your ETA doesn't work, you can do this manually. Let's say we're gonna go to Google now.
Yeah, I think we just lost our internet. Okay, checking. Ah, the internet should be fine.
All right. Cool. Well, what we want is JUnit and Maven Dependency.
Yay! Autocorrect. No, autocomplete. Autocorrect is the bad thing.
No, it's a good thing. Anyway, if you search for any kind of library and you add a Maven dependency, what you're going to be finding is something like this. You have version history of this library that you search for. I'm just going to take the latest one. And over here is an XML definition of this dependency. So this basically describes this specific library. You can take this and you can add it to your project description. In case of a Maven, it's the POM file. This will have here. In the POM file, you can define, I have dependencies. And now you can add all of the dependencies that this project will use. You just copy paste that in there. And see, it is so smart, it realized, hey, you added a dependency. Would you like to automatically download it? I'll press enable auto import. This means whenever I write a new dependency here, it will automatically go and try to fetch it from the servers.
Yay!
So if you noticed, it was red before, but now it found it, and boom, it isn't red anymore. And now if we go our test, it has found it. It found it and it's green. Nice. So technically, we have a testing framework now, and we can try to write a simple test.
So basically, what this class name that Max wrote tells us that we should have a hello class somewhere which has tests, right?
Yeah, that can be one way. There are many ways to write tests or how to categorize them, and one that Sash just explained was that testing each class. So if you have like a class called car, then you're gonna write a test class for it called car tests. Or if you have a class of customer, then you will write customer tests for it. There are different ways you can organize. That's one of the good ways. So, but at the moment we don't really have a hello class, but we can still try out different things, or add a hello class later.
Yeah, I was thinking that we're gonna make this test that is not working, so we have to make a hello class that has the working test.
I just wanted to quickly test out if the framework works at all.
Okay.
So I'm just gonna try out assert true. Haven't used that. This way. How do you get this to import? I've been using different data for so long. I'm having trouble here. How do you import this?
This one should be it, but it's not seeing it.
JUnit framework. Alt enter. That's the key. Now there we go. I want to import, and I want to import the JUnit assert. There we go. Okay, importing was what I was trying to find.
Okay. So now if we run the test, it should...
What I wrote there is basically an assertion. Assertion means that you're going to assume something. And this is kind of a redundant test, as it currently is going to assume that something that is true is going to be true.
But yeah, the naming convention of this test is bad. So we want to test our hello world program.
Okay.
So it's gonna be hello world test. So
it's gonna be a method, so it should start with a lowercase.
Oh yeah, of course, derp. derp. Already making mistakes. So and now we just want to call out a method and assert that the strings are matching. So basically, we want a hello world response.
So this is going to be a test that will try to test a class and see if it will say hello world to us. So in a test-driven development way, we're going to write the test first. So we're going to write a test and we check for hello world using assert equals. Yeah, you can pick anyone. You don't really have to find the right one. So
Worlds.
Of a hello class, perhaps, or
Yes, this is the class that we are gonna test.
So even though it's currently underlined with red, meaning that it has errors in it, what Sasa has written here is that he's gonna expect a hello world string as a response from a method called print hello world, and that should happen in a hello class. But since we don't have that class, this whole test is currently red. And the test-driven development way is that you write the test first, as we have done now, and you try to run it, and you get an error. It means, hey, I can't find the variable hello or the class hello test. Now, in the class hello test, okay, we can't find the class hello, so we should try to implement that. Let's create a class hello, and it will be created in source main Java. That's great. And okay, we have a hello class here. I'm going to remove these useless lines. And now that we have a hello class, the thing is, during the test-driven development, you want to take as small steps as possible.
So basically, the more you press the play button or the compile button, the better.
Yeah.
So if you are not doing with tests or developing without tests, usually you have like half an hour to write code, 15 minutes to make the code compile, and then you're gonna start to debug. What the test-driven development makes you is press the play button like every 2 or 3 minutes. So you just all the time you are compiling the program.
Yeah, you're taking as small steps as possible. And I think it's really great for the viewers as well, as they don't get distracted. I mean, if we're going to write some kind of other code for like 15 minutes straight, oh, I'm just going to add a library here, and then I'm going to call out that thing, nobody's going to be able to follow us. But if we take these like small steps, and we always press the play button and show that, hey, currently this is the problem, and it doesn't compile, or this thing is missing. Okay, so what happened last time, now we pressed the play button and we got another error saying that the method print hello world was missing. So Sas now added a method called print hello world and made that method return a string.
I'm doing something wrong.
So maybe we need to create the class or make it static. Any one of those will do. We can make it a static method.
Yeah, so we can call it from everywhere we want.
Yeah. Or just to avoid using static, because static might be something that will take a long time to explain to somebody who hasn't used it. Anyway, if you're gonna get into programming, I'm pretty sure the lecture you're gonna take on programming will cover the static, so we're gonna have fun with that. But we're just right now gonna go up, create a variable. It's gonna be the type hello class. This class is gonna be a hello class, and getting used to Estonian keyboard. Hello. So we created a new hello class, and now over here we can take this class and ask it to print hello world. So if we run this, by the way, what was the shortcut key to run? It was Control F9.
I'm not sure.
Yeah, it was run. Alt 4.
And remember, this is not F4.
Alt 4. Alright. Alt 4. Yeah, it's running. That's cool.
So basically, we got our first tests running, which is awesome, I guess.
That is great. See, now that you have a test, let's imagine that we have been writing the software for ages and ages, and we want to come back and make a small change to it. And for some reason, we mess around with it and make a typo in here, and we add some kind of letter. You don't really notice it, and you forget about it. So now that if you would run the tests again, the tests would fail. See, they've man. How was this now? Okay, it's not here. Alrighty. Alright, if I run the tests again, yeah, it would tell you that hey, something changed about the software.
So what happened here was that we didn't run the correct test. We just ran.
Yeah, that was the last. That was the last error that was in there in between.
Yes.
But yeah, if the test fails, you'll see that expected message was hello world, but actually we had hello worldy. So there's a difference here.
Yay! And now we can find the mistake,
Yeah.
fix it, and run the thing again, and it should be all green. Yay!
Very test passed.
So basically, now that we have introduced the very basics, we can start thinking about our program.
Yeah, I guess we can. So the way I imagined is that we have some kind of a player class, right?
Yeah. What I want to do is leave the player class for later.
Okay.
At the moment, let's just make a bunch of monsters and put them into a pit and make fight to the deaths.
All right. That sounds.
How does
cool.
that sound?
Yeah, that sounds cool. Alrighty. So.
So this is a good place to make a stop. We're gonna take a 5-minute break and continue then.
All right, you guys can try to think of different monsters to add. Goblins
Yay.
or werewolves or vampires.